Okay, number 8. What'd you have for that one, Shanty? The cosine of x on top? I'm trusting that. It is the cosine of x. Okay, number 9. What'd you have for that one in the end, Aiden? 1 is the answer. Good job. Number 10. What'd you have for a final answer for that one, Justine? 1. It is 1, right? Not -1? Or is it -1? Everybody got 1? Okay, we're good. 11. Okay. Could be a couple different answers here. Could be 1 minus sine squared of alpha, but you know 1 minus sine squared of alpha is cosine squared of alpha, right? So I'd rather have that. Number 12. Okay. We have secant of alpha plus 1, secant of alpha minus 1, right? So if we FOIL, we get secant squared of alpha. Outers and inners are going to cancel here, minus 1. Now, is this a Pythagorean identity of some kind? Which Pythagorean identity is it? Tangent squared of alpha. Okay, because secant squared of alpha equals tangent squared of alpha plus 1, right? So if we subtract 1 from each side, secant squared of alpha minus 1 equals tangent squared of alpha. Now, I'm supposed to write it in terms of sines and cosines. How do I write this in terms of sines and cosines? What's tangent squared in terms of sines and cosines? Sine squared of alpha over cosine squared of alpha. So this was my final answer here for 12. 13. Cosine of beta. And I'm just, when they go into betas and stuff like that, I just go X because it's quicker to write. So if you want to do it that way, instead of writing betas and stuff like that, that is just fine with me. All right. What's the only thing I should change right at the start? Tangent. So cosine of x, sine of x over cosine of x, plus 1 times sine of x minus 1. What's sine over cosine? Well, what happens there? Cosines cancel, so it's sine of x plus 1 times sine of x minus 1, which is sine squared of x minus 1. Okay. If you want to change that, that is equal to negative cosine squared of x by a Pythagorean identity. Now, if you left it like this, would I count it wrong? Nah, probably not. I'm probably fine with that. Okay. 14. 1 plus cosine of x times 1 minus cotangent of x sine of x. Okay. So what's the only thing I change? Cotangent into cosine over sine. It's cotangent. So cosine over sine. Those cancel. 1 plus sine, 1 plus cosine times 1 minus cosine is 1 minus cosine squared of x. Because the outers, if you do the outers and the inners, they're going to cancel because they're conjugates. Okay, what's 1 minus cosine squared equal to? Sine squared, a positive sine squared of x. Okay, we doing good with this? 1 plus cosine of x tangent of x cosecant of x all over cosecant of x. What's cosine change into? Nothing. It stays as cosine. What's tangent change into? Sine of x over cosine of x. What does cosecant change into? 1 over sine of x over 1 over sine of x. So cosine and cosine cancel. Sine and sine cancel. What's 1 plus 1? 2. So you get 2 over 1 over sine of x. This is a complex fraction, isn't it? How do you simplify a complex fraction? Multiply both the numerator and denominator by the denominator of the denominator. These cancel, so we get 2 sine of x. That's our final answer. Last one. Cosine of x tangent of x plus 1 times sine of x minus 1 over cosine squared of x. Okay, cosine tangent is cosine of x, sine of x over cosine of x plus 1 times sine of x minus 1 over cosine squared of x. What can I do there on the top? Cancel out cosines. So I have sine of x plus 1 times sine of x minus 1, which is sine squared of x. Outers and inners cancel. Minus 1 over cosine squared of x. What's sine squared of x minus 1 the same as? Nope. It is not cosine squared. Negative cosine squared of x. Which equals to be? Negative 1 in the end. There we are. Okay? That's the basics of yesterday. Okay? All right. Today, 3.1b. We're going to work with Pythagorean identities today. What are our 3 Pythagorean identities? What's the first one? Sine squared of x plus cosine squared of x equals 1. What's the second one? Secant squared of x equals tangent squared of x plus 1. What's the third one? Cosecant squared of x equals cotangent squared of x plus 1. Okay, those are our 3 Pythagorean identities. Let's say I want to write tangent in terms of secant. Write tangent in terms of secant. Which one involves both tangents and secants? First one, second one, and third one? Second one. Okay, so I want to write tangent in terms of sequence. So I want tangent alone on the left. So I'm going to write tangent squared of x plus 1 equals secant squared of x. How do I get tangent alone? Minus 1. So tangent squared of x equals secant squared of x minus 1. Then how do I get tangent alone? It's tangent squared. I need tangent alone as just tangent. Square root. Tangent of x equals positive or negative the square root of secant squared of x minus 1. Okay? So that's writing tangent in terms of secant. That's an easy one. Okay? Let's write cosine of x in terms of tangent of x. How do we write cosine in terms of tangent? Ooh. Okay. Do any of these involve both cosine and tangent? No. Is there something that involves cosine that's easy to put the other term in terms of sine or in terms of tangent? Can we change sine into tangent really easily? No. Here's a tangent one. Can we change secant into cosine really easily? Yes, we can. So I'm going to use that one. I'm going to say secant squared of x equals tangent squared of x plus 1. Okay? Now, how can I change secant into cosine? Reciprocal. Secant squared is 1 over cosine squared of x. But I need cosine on the top. So what do I do to each side? Reciprocal it. I just reciprocaled it. Take the reciprocal of both sides. Ah. I reciprocaled it. Are you going to reciprocate my reciprocal? I'm just kidding. That didn't make any sense, did it? Then I take the square root of each side, right? Because I got to get cosine alone. So the cosine of x equals, what's square root of 1? 1 over the square root of tangent squared of x plus 1, right? Can we leave square roots on the bottom? No, you don't leave square roots on the bottom until you get to AP Calc, and we just say, yeah, that's fine now. You can leave them on the bottom. But until AP Calc, no. So how do we get a square root of tangent squared of x plus 1 off the bottom? Multiply by the denominator. So the cosine of x is equal to positive or negative the square root of tangent squared of x plus 1 over tangent squared of x plus 1. That's cosine in terms of tangent. Was that nasty enough? Okay. Let's write secant in terms of cotangent. Ooh. Secant in terms of cotangent. Now, in the secant one, what does secant have going with it? Tangent. This says cotangent. In the cotangent one, what does cotangent have with it? Cosecant. Is it easier to change a secant into a cosecant or a cotangent into a tangent? Cotangent into a tangent. You're right on that one. Okay? So, we want secant in terms of cotangent. So, secant squared of x equals tangent squared of x plus 1. Now, this is going to be a crazy one. I don't think you'll have one quite this hard on your homework, but here we go. If you can understand this, you'll be just fine. Okay, so I got to get tangent in terms of cotangent. How do I do that? Reciprocal. 1 over cotangent squared plus 1, right? Then I would like to take the square root of each side, but there's too complicated on the right side. So what I should really do, here's what I need to do, is get a common denominator so there's one fraction there. What's my common denominator on my right-hand side? What's my only denominator on my right side? Cotangent squared of x. So I change my 1 into cotangent squared of x over cotangent squared of x. Oh, isn't that so easy once I throw it up there? Okay, so I got a common denominator. So secant squared of x equals 1 plus cotangent squared of x over cotangent squared of x. Okay? Now, what do? Square root it. Because I want secant in terms of cotangent, so I take square root of each side. Secant of x equals positive or negative the square root of 1 plus cotangent of x squared over cotangent of x. No square roots on the bottom anymore. All right, craziness. So that's going to be half your assignment, is ones like that. Yeah, I mean, how long have we been in here? Yeah. We get out of here at 27. We got it. Okay, maybe I won't give you the full second half of the assignment, but we're going to do a few more problems. All right. The second part of the assignment is what if I have the cosine of x equals 3/4 in quadrant number 4. How do I find the other 5 trig functions? Using Pythagorean identities and other identities, not drawing out a circle and using triangles, because we've already learned how to do that. Okay, I want to use Pythagorean identities and trig identities. Yeah. All right. So we're going to get some nasty fractions here for a few of them. But I want to find out what the sine of x is, what the cosine would be next, what the tangent of x is, what the cosecant of x is, what the secant of x is, and what the cotangent of x is. Okay? Now, out of these 5, what do you think is the easiest to find out of those 5 using just your identities on your note card? Secant. Yes, Shanty. You got trig down. You got trig in your blood. What's a secant? What's a secant? It's just the reciprocal of cosine, right? What's the reciprocal of 3/4? 4/3. Boom! Done. Easy peasy. Lemon squeezy. Okay? Super easy. There's always going to be one that's going to be the reciprocal of it. So you find that one first. All right. Now let's use trig identities. Now, we know that sine squared of x plus cosine squared of x equals 1, right? So sine squared of x plus 3/4 squared would equal 1, right? Sine squared of x plus 9/16 equals 1. What do we do to each side? Subtract 9/16. Sine squared of x equals 7/16. Because 1 is 16/16. 16/16 minus 9/16 is 7/16. Then what do we do to get sine alone? Square root. What's the square root of 7? Square root of 7. What's the square root of 16? 4. So it's the square root of 7 over 4. But not so fast, my friends. We're in quadrant number 4. What is sine in quadrant number 4? Negative. Very good. Negative. Now, what's easy peasy lemon squeezy once we know the sine? The reciprocal. What's the reciprocal of sine? Cosecant. So my cosecant function is 4 over the square root of 7. Can we leave the square root of 7 on the bottom? No. We're not in calc, so we can't do that. So we multiply top and bottom by the square root of 7. So it's negative 4 square root of 7 over 7. There's cosecant. Okay. What's my next one that I'm going to find? Either tangent or cotangent, right? Secant is kind of a nice number here. 4/3. A lot prettier than that bad boy, right? And prettier than that one. So why don't I use my secant? What Pythagorean identity is my secant one? Secant squared of x equals tangent squared of x plus 1. So what's my secant? Well, it's 4/3. 4/3 squared equals tangent squared of x plus 1. What's 4/3 squared? 16/9. If we subtract 1 from each side, then what do I get? 7/9. Come on, man. Because you're subtracting 9/9 from each side. Shanty, did you catch that? Okay. Now what do we do to each side? Square it. Square root of 7 over 3 equals tangent of x. So tangent of x is square root of 7 over 3. Is it positive or negative? Negative. Quadrant 4. Negative. So then what would the cotangent be? 3 over square root of 7. Can we leave square root of 7 on the bottom? No. So it's negative 3 square root of 7 over 7. That's all my trig functions using Pythagorean identities. If you'd use a triangle, you get the same exact answers. But let's not use a triangle because I want to see you using Pythagorean identities. How about we stop there? Page number 165. We are doing 17 through 24, all of them. Now, do not throw away your first assignment. Do not lose your first assignment, your 7 through 16 all. Because at the end of section 3.1, we're going to wind up doing like number 7 all the way through number 38. And then we're going to do 61 through like 64. So we're going to do all those problems. And then I'll come around and check them once we get done with section 3.1. So we've got 1, 2. We should finish this on Tuesday. We should finish section 3.1 on Tuesday. So then next Thursday, I'll come around and grade section 3.1 for completion. Does everybody understand? Okay. Oh, hopefully, Autumn, you caught that.